Hello everyone, welcome back to this video series. So in today's video we have a very interesting question to solve. I've been given a complex number and we want to look for the equivalent expression. So the first thing we need to do when we have any complex numbers to solve is to have it in mind that for any complex number, let's say z equals to a plus bi, then a is a real part and bi is the imaginary part. We could still represent this as x plus iy. It's still the same thing. X is the real part and iy is the imaginary part. We also have to have it in mind that we have I squared is -1, or better still, I to be equivalent to the square root of -1. So once we have this in mind, we can proceed with any calculation that we are faced with. So now we have been given this complex number. The first thing we need to do is to equate this to a complex number like z that we have here. So we are going to say, okay, let our square root of I to be equals to a plus bi. Now if we are able to get the value of a and b at the end and substitute it here, therefore that value or those values will be equivalent to the square root of I. Now we have a complex number, and to solve any complex number, and in fact to solve any square root, the first thing we need to do is take squared on both sides. So if you square this, we are going to have I on the left hand side to be equals to, now we are going to have a squared, and bi all that squared is going to give us minus b, now plus 2 abi. Now this is equivalent, this is the expansion of this above. Remember that this is actually squared, so that's squared. So that's the expansion above. Now we have to express our I as a complex number, because I is a complex number, but it doesn't really look like a complex number in the form a plus bi. So to do that, we are going to see that 0 plus 1i will be in this form, meaning that the real part is 0 and the imaginary part is 1i. Now this will be equivalent to a squared minus b squared. Now since this doesn't have the I or the complex constant, therefore this is the real part. Now plus 2 abi, and this is the imaginary part. So this is actually our real part of the complex number, and this is the imaginary part since it contains the I. Now from equality of complex numbers, two complex numbers are equal when the real part is equal to the real part and the imaginary part equals to the imaginary part, meaning that 0 is equal to a squared minus b squared, and 1 is equals to 2 abi. So we have two equations to solve, and as always, for two simultaneous equations, you can either go by elimination method, substitution, graphical, and matrix method, depending on which one works best for you. But in this case, substitution is the best. Now from equation 1, we see that 0 is equals to a squared minus b squared. This simply means that a squared is equals to b squared, which implies a is equals to b. We can call this our equation 3 and keep that in mind. Now if we set equation 3 in equation 2, we're simply going to see that from equation 2 we have 1 should be equals to 2. Now what is our a? Our a is b and b remains b. So we're going to have 1 to be equals to 2 b squared. I want to look for the value of b. So b squared, this implies that b should be plus or minus the square root of 1 on 2, which is the same as plus or minus 1 all over the square root of 2. Now we have that in mind as b. We saw that from equation 3, a is equal to b, meaning that our a is also plus or minus 1 all over the square root of 2. We said initially that the square root of I is equals to a plus bi. Now we're going to substitute here. We have now the square root of I to be equals to a. We saw that our a is plus or minus 1 all over the square root of 2, and our b is plus or minus 1 all over the square root of 2i. So this is a complex part and this is a real part. Now from here we can actually get 4 solutions if we play around with the signs in front of the plus or minus. So from here our first solution for I will simply be, we will consider the positive part of the real part. We are going to have 1 all over the square root of 2, and we consider the positive part of the imaginary part. We are going to have plus 1 all over root 2i. So this will be equivalent to 1 plus I divided by root 2. So we're going to do the same thing. We consider the negative part and the negative part, the positive and the negative part, and the negative and the positive part. We're going to end up with something like 1 minus I minus 1 minus I all over the square root of 2. That will be like the second equation, the second solution. The next one will be minus 1 minus I all over root 2, and the other one will simply be 1 minus 1 plus I all that root 2. So this will be the solution of the square root of negative I. So those are the various solutions for the square root of negative I. There are actually 4 of them. So yeah, that's it for this video. Please, if you found the video helpful, give it a thumbs up, and you can always put in the comment section any video you want me to make. So yeah, that's it. So as always, wish you all the best and see you in the next video.